Very good morning, and thank you, Ashok, for the invitation. And I think we can skip that. So I think the stage for me is incredibly well set up by my colleague, Professor Getu, because he talked about two important things. He talked about the fact that we need to relook at how we maintain our infrastructure. He also talked a lot more about the fact that we need better codes and standards. We also need innovation. So I'm going to just take you to a small journey that I have encountered as a part of my journey here at IIT Madras over the last 15 years or so. So I'm going to talk more about physical infrastructure, but less about concrete. I think here, Professor Getu talked more about cementitious material. I'm going to talk about more metallic materials. And metallic materials, including cementitious mixtures, are a big part of our infrastructure. And this covers everything that you can see. And interestingly, India is today in the top 4 or 5 in most of the infrastructure that we're talking about, whether it's roads, whether it's dams, whether it's railways. We are there up in the third or fourth tier. And what is important to understand is that we aspire to be near the top 1 or 2 in the next 15, 20 years. So the question is, can we build these infrastructures from grounds up, or do we go a hybrid route where we need to maintain them? We need to find strategies to maintain them better. So I'm going to talk a little bit about these kinds of things, and even, for instance, talking about cross-country pipelines. No, I think very few of you may be aware that India has one of the largest networks of underground cross-country pipelines, whether it's transporting gas, oil, iron ore. It's aspiring to go to over 100,000 kilometers not very long from now. So how do we maintain these things? How do you make sure that the gas pipeline going under your house is safe? And it will last you for many, many years. And the problem is not simple. As the previous slide shows, we have the largest networks. That means the problem is very, very large. You have incredible amount of material to be ascertained, and the asset monitoring of these structures becomes very difficult and very expensive, and the cost constraints will drive the usage and the maintainability of these infrastructure. And just to give you one example, one of the most difficult problems of aging infrastructure is corrosion of metals, and steel being the biggest culprit here. Corrosion is a $1 trillion problem today worldwide. In India alone, it's about close to $100 billion problem. So it is not simple, it is not small. How do we solve these problems? You have to now look at technology. And technology means robotics, robotic inspection, health monitoring, which means just the way today we are talking about putting blood sugar sensors onto your arm and then be able to monitor your sugar levels. Very similar technologies. Can I do the same for the oil that's going inside your aircraft or your automobile? So as a center of excellence at IIT Madras, we are about 21 years old at the Center for NDE. We focus on asset integrity monitoring, and our goal is very much supported by many startups. And I want to talk a bit more about the innovations component in that we have almost every year since we started the first company in 2010, almost every year since 2015, there's been a company that's come out of our center. There's totally about 10 companies, about 500 employees, valuation of the order excess of 100 million for sure, probably going up there, and a lot of IPs being created from only one center of excellence in IIT Madras. We have more than 60, 70 centers of excellence in IIT Madras. Can you imagine the scalability of that just in our ecosystem, and then project it to probably the top 50 STEM institutions in the country? You're talking of a huge economic value that can happen in this country. And I think it's already happening. But we just need to find ways to do it better. It's just not in India. These companies and our center has presence for global footprint. US, Europe, even South America. And we are expanding as we go along. So this is a very critical aspect, that we develop technology, we innovate in technology, we test it in India, but then it is for the globe, for the global needs. Infrastructure have to be maintained, whether it's underwater, whether it's above the ground, on the ground, or whether it's high up above the ground. And we have companies, each one specializing in that. In fact, you'll hear a lot more about Detect Technologies 2 days from now on 9th morning. I think 11.3 is the session number, where Tarun Mishra, the CSO, is going to talk about the innovation that they're doing using drone-based technologies and camera-based technologies and making industrial processes and facilities more safer. I'll go a little bit more into physics today because being a faculty. You all know that sound wave is what I'm using to communicate to you. Now sound wave is, in my case, open in the air, but you can also confine it to what are called waveguides. Like, for instance, when you did as a kid, talked about this telephony, the wave is confined to this particular wire. So it allows you to communicate better. Now, can I use this for something beyond communication? The answer is yes. I can actually create a sound wave. It travels along this vinyl flooring, and then if there's something happening on the other side, I can determine what's happening on the other side. And that is what is called the guided wave. This is a very simple technology, well known from 1900s, early 1900s, when Lord Rayleigh actually found this phenomenon. So the question is, we need to solve industrial problems of corrosion. Here's a good example of a corrosion problem here, wherein we have a pipe that is being put on a support. And you know the pipes can't be unsupported for very long distances. So every 10, 15 meters, there's a pipe support. And that's exactly where corrosion happens. So always corrosion happens where it's very difficult to find. So how do you go underneath that? These pipes are heavy. Okay, so you can't just lift them. So example of a journey that we had was early 2000s. We were actually contracted by BPCL to look at this problem. We came up with what's called a low frequency guided wave regime. Then subsequently, after the project was over, one of my students accidentally discovered that you can actually do this at high frequencies also. Now, in order for the innovation to really be carried forward, you need support. You need support from government in terms of funding. You also need support from an industry who is willing to let you go and access their facilities. We got that through ExxonMobil. So for 5 years after we discovered this, the aha moment to acceptance was 5 years of hard work globally, going to different places. And that's where we actually had the help of a startup from IIT Madras that actually was willing to do that and bet on it. And that today has led to more than 20,000 pipe supports being inspected every year, literally. An example is shown here. This is High Sea in Brunei, where our technology is being inspected, used for ensuring that this boom, which is going to carry a lot of weight, is actually safe. Another example you see here is where we have these storage tanks. I don't know, anybody who is just landing on any airport will see these big storage tanks. These are small ones actually. The bigger ones are if you go North Chennai to where CPCL has its factory, or you go to any other places around the refineries, you'll see hundreds of these storage tanks. These are very critical assets. You also have underground storage tanks. Now, one of the problems is corrosion. You see that if this happens near the end of the wall, you have a catastrophic failure. It can not only damage that particular storage tank, it can also take out the neighboring storage tanks. And these products, being extremely hydrocarbon oriented and explosive in nature, can cause very significant catastrophic damage. So here is an example of this company actually going and creating an acceptable, standardized commercial product that is now worldwide used, all developed in India, in this city of Chennai, and be able to inspect for these corrosion in these storage tanks. Today we have more than about 1,500 storage tanks under our inspection. Every 3 years we actually inspect these storage tanks. Our clientele includes who is in the oil and gas industry: ExxonMobil, Shell, Reliance, BPCL, IOCL, you name it, we have them as our client. And we are able to do this automatically. We are able to scale this. We are able to expand it across the globe. And that is purely because of the innovation quotient that is available in this particular technology. And there is no competition for this technology today. And that is very important. So I'll skip that. And just to conclude that it takes a partnership. It takes a partnership for government, academia, industry, and today we are including a startup as a fourth component. And this particular forum being a very good example of how we are mixing different stakeholders to create value that is scalable, where it makes India proud across the world. And today we have, in fact, Baker Hughes, which is one of the largest oil and gas industry company in the world, being a partner who is actually now taking us to newer clients. But we already have clientele as big as Exxon, Shell, Bharat Petroleum, Reliance, who are our regular users for this technology. As we speak today, I can tell you that there are at least 4 or 5 locations in the globe where this technology is being implemented every day. So with that, I just want to stop here.